Hello Year 11 and welcome to this first video for our second topic. Integers and rational numbers is the title for this video. We'll be looking at some other things as we go along. Quick introduction though. Integers, whole numbers. Negatives, 0, positive numbers, they're fine. No decimals, no fractions, just whole numbers, they're integers. Rational numbers can be written as a fraction, right, as one integer divided by another. Now the multiples of some number is when I take some number and multiply it by an integer. Right, so you know the multiples of 3, 6, 9, 12, 15 and so on. The lowest common multiple of two integers, a and b, is the smallest number that is a multiple of both. So for example, 6 is a multiple of 2 and it's a multiple of 3. So the lowest common multiple of 2 and 3, in this case, happens to be 6. 12 is a common multiple of 2 and 3, but it's not the lowest common multiple. What about 6 and 8 here in the example? Well, look, if I write 6 as 2, if 6 is 2 by 3, and 8 is 2 by 2 by 2, right? What I've done here, this is the unique prime factorization of those numbers. Right, we break it down to a product of its prime factors. So what I'm after here is I need a list that includes, includes the factors from both of those numbers. So I need a 2, it's not working, 2 and a 3. Oh, and I need some more 2s. Okay, can you see here, this list of factors has the 2 and the 3 from the 6, and it has the 3 lots of 2 there, the 3 2s from the 8. So that's my lowest common multiple, and if I work that out, I get 3 8s, 24. Okay, so if I just did 6 times 8 and got 48, yep, it's a common multiple. That will always be a common multiple. It's not the lowest common multiple. Now the integers from 1 to 10, the lowest common multiple of all of those. Well, if I have 1 times 1, 2, 3, now 4 is 2 times 2. I can put commas in here. 2 times 2, then we've got 5, 2 by 3, that's 6, 7, now 8 is 2 by 2 by 2, 8, 9 is 3 by 3, and 10 is 2 by 5. So I want a list that includes all of those. So I need a 1. Well, we can always, the 1's always there. We'll leave 1 out. I need a 2. Right, so that's that done. I need a 3. It's done. Now 2 by 2. Well, I've already got 1, 2 there. So another 1, and that's 4 taken care of. Now I need a 5. Now 6, 2 and a 3 already there. So that's good. I need a 7 in my list. No, that's my 7. Now 2 by 2 by 2. Well, I've already got 2 of them. I'll need another one. Okay, and that's 8 taken care of. 9 is 3 by 3. I don't have a pair of 3s in this list. Let's put another one there. That's good. Taken care of. And then a 2 by 5. Right, I've got a 2 and a 5 there. That's it. So this number here, if I expand that out, the product of all of those, 6, 12, 60, 420, 840, 2,420, I think. 2,520. Hang on. So there you go. 2,520 is the lowest common multiple of all of the integers from 1 to 10. 2,520 can be divided by any number left between, 1 and 10. Divisors and HCF being highest common factor. Divisors is something that can go into a number, right? So the factors, if you like, not necessarily prime factors. And highest common factor, right, is the largest number that's a factor of, two others. So 60 and 72. If we write these out as a pair of, with their prime factorization, 60 is 2 by 2 by 3 by 5. Okay. So 2 by 2 is 4, 4 15, so 60. And 72 is 2 lots of 36, which is 2 lots of 18, which is 2 lots of 9, which is 3 lots of 3. Okay, so we've got those two numbers. Now what I'm after is I want to pair them up. Okay, instead of writing a list that contains all of those, I want to find what's common to those. So I've got a pair of 2's. I've got another pair of 2's. I've got a pair of 3's. Is there anything else that's common? Or 5 here, no 5 over here. So the highest common factor of 60 and 72 is 12. Right, like that. Rightio, that's it for, oh no, a little bit more here. Prime numbers. Prime numbers can only be divided by 1 in itself. I'm sure you're familiar with these already. I've mentioned previously here, around and about, that the prime factorization of a number can be very helpful for solving some of these problems, and every number has a unique prime factorization. Okay. 60, for example, we said was 2 by 2 by 3 by 5. Other than changing the order of that, there's no other way to multiply prime numbers together and get to 60. You need a pair of 2's, 3 and a 5. The only way you can multiply primes and get 60. Rational numbers can be written as a fraction, and a reminder, when we're multiplying fractions, multiply the numerators and multiply the denominators. When we divide by a fraction, we multiply by the reciprocal, turn the second number upside down, and multiply. Okay, that's it for the first video. If you've got any questions, jot them down, ask me in class. See you there.